A porcelain chatbot lays brick after brick. The bridge looks solid. It just ends in thin air. Step on it and you fall. If you've ever pasted a chatbot answer into something that truly mattered, you were standing on that bridge. Why does AI invent answers? And how do you catch it before it costs you? Here's what's coming. The guess, next token, confidence trap, spike zones, and your checks. That's exactly how your AI answers when it doesn't know. Hallucinations, an episode of the AI Actually series. Your AI isn't lying, it's guessing. Here's the math. If you have ever trusted a chatbot fact and later found it invented, this is for you. No code needed. By the end, you will catch the guesses yourself and know what to check. 5 stages. First, watch one real guess land. Researchers asked popular models one simple question. What was the title of Adam Kalai's dissertation? One model answered with a full, confident title, Boosting, Online Algorithms, and Other Topics in Machine Learning, finished 2002. 2 other models invented completely different titles with the same easy confidence. 3 confident fabrications, 0 matches. They did not lie. Confident wrong answers appeared with no retrieval behind them. Why does the machine always finish the sentence anyway? That brings us to stage 2, next token, the next small chunk of text a model writes. A token is a chunk of text the model treats as one piece, a word, part of a word, or punctuation. The model never searches a truth database. The model scores every possible next token and picks from the most likely, given everything so far, exactly the way your phone's autocomplete finishes, I am going to the with store or park, because those patterns appear constantly in what people type. During training, its only job is to match the patterns of human text, and the score that shapes it never once asks whether a sentence is true. A fluent falsehood that looks like training text scores just as well as a true one. That's the math of guessing. Back to those earlier fabrications. The prompt ends with title of, the model has seen thousands of thesis titles that sound academic and specific. It has almost never seen the exact rare title. So it samples a plausible academic-sounding string that fits the pattern of dissertation titles. Different runs sample different high-probability phrases. All sound right. None match. The pass-fail rule is simple. Does the string match the actual document? It fails every time. One change that helps later is giving the model the real document first. Without it, pure guessing wins. The takeaway, it always produces the most plausible continuation. Truth isn't scored. And that number is useless if the voice still sounds certain, which brings us to stage 3, confidence trap. Why does a wrong answer sound so sure? Because confident language is itself a pattern in the training text. The model learns the style of certainty from millions of authoritative sentences without ever learning the conditions that make certainty deserved. So confidence and correctness end up completely uncorrelated. Training and tests make it worse. Most benchmarks give 1 point for a right answer and 0 for, Guessing can score. Admitting uncertainty never does. Like a student on a multiple-choice exam who leaves nothing blank. Leaderboards reward guessing, and models trained to win them hallucinate more. OpenAI researchers proved it with a benchmark called Simple Quai. The model that guessed at everything nearly tripled the error rate of the careful one and still ranked higher. The takeaway, confidence is style, not a truth meter. That style fails hardest on certain questions, which brings us to stage 4, spike zones. Hallucinations spike on rare facts, invented citations, and multi-step math. Rare facts appear once or never in training, so no reliable pattern exists. The model still has to emit tokens, so it invents a plausible one. Citations look like author year journal page, an easy pattern to complete even when the paper never existed. Math fails when the model predicts the next digit instead of calculating. Ask it to count letters in a word without step-by-step, and it often misses. Giving the model real documents changes the game. Retrieval Augmented Generation RAG pulls documents that actually match your question and makes the model continue from them. So the next tokens lean on real text instead of pure memory patterns. It's not magic. Retrieval can miss and synthesis can garble. But now the guess has a source you can open and check. Takeaway: spikes hit rare, cited, and calculated claims hardest. Grounding gives the model real text to lean on. Now you need moves you can make today. Stage 5, your checks. 4 quick checks catch most guesses. Skip them and you risk building on thin air. Do this especially on rare names, exact quotes, and math results. Try the dissertation question yourself. Demand the exact title and year with a source. Rephrase as what year and university. Force the if unsure rule. Then search the real name plus dissertation. You will see the invented titles collapse the moment real search results arrive, and the actual 2001 Carnegie Mellon document takes their place. One verified case that trains your eye for every answer after it. You can now tell a confident guess from grounded knowledge and run 4 quick checks. Skip them and you risk building decisions, reports, or code on thin air, wasted hours, or worse. Homework. Pick one fact your own chatbot gave you this week that mattered. Predict whether it will survive the 4 checks. Then run them. Notice what still fails. Your AI isn't lying. It's guessing the next most plausible token, and truth was never in the score. Like this video if it changed how you read chatbot answers. Subscribe for the next episode. Quick question for the comments. When your chatbot sounds most sure, do you A, trust the tone, or B, run a check first?